Let's try to summarize what we have learned until now on vector product. First, we learned that to find the vector product of A cross B, let's say, you can just find the magnitude using AB sine theta. You can write it this way with the right arrow and the modular sign, or you can write it without the right arrow and the modular sign. Again, the theta is the angle between vector A and vector B. That's the magnitude. For direction, we learned that we can determine the direction using right-hand rule, which was demonstrated in the previous video. The second thing that we learned that if the angle between vector A and vector B, or any two vectors that you put inside the vector product, is near or approaching 90 degree, then the perpendicularness will be greater. If the perpendicularness is greater, then the result of your vector product will be greater. Okay, on the other hand, if your angle is approaching 0 degree or 180 degree on the other side, then you have less and less perpendicularness. Okay, so if you are getting less and less perpendicularness, you should expect a smaller result for your vector product A cross B. Okay, so we are talking about magnitude here. The magnitude will increase or decrease depending on the angle between the two vectors. Okay, then the most recent thing that you have learned just now is also that vector product does not obey the commutative law. Even though when you commute between A and B, right, even though the magnitude is still the same, the issue that we face is the direction of the vector product will be flipped to the opposite if you commute between the two vectors. And that's why we say that vector product here does not obey the commutative law. Okay, so let's try and visualize these three things here on the diagram, okay, in a more pictorial way. So let's say today I still have my same A and B that we have used many times. So if you want to find the vector product, let's say the magnitude of vector product B cross A, now I'm doing B cross A, then you can find it using AB sine 45 degree, or I can find it using BA sine 45 degree. No matter what orders, B times A times B, it will still be the same. 3 times 5 times 3 is the same. Okay, but now again I give it a bit of meaning by grouping together A sine 45 degree together with inside a bracket and B is outside the bracket. So now you can think of it as me resolving vector A to find the component which is perpendicular to vector B. Why do I say perpendicular? Because sine means opposite, right? So opposite should be on this side, which is equivalent to this component of A over here. So this component of A here can be represented by A sine 45 degree, and we see that this component here can be also known as the component that is perpendicular to another vector, vector B. Okay, so we are finding the component of A which is perpendicular to B, then multiply with the magnitude of B. That's how we find the magnitude for B cross A. Okay, so now we are going to move on to the second point, which is the greater the perpendicularness, the greater the result of our vector product. Now I'm going to prove the other way around. I'm going to prove if we decrease the angle, you will decrease the perpendicularness, and thus you will decrease the result of your vector product. How am I going to prove it? The same idea. If today I shift my vector A, I decrease it by 10 degree. So now it's 35 degree. If I put in 35 degree here, essentially what am I doing is I'm finding the component which is perpendicular to B. And now as you see, the component of A that is perpendicular to B has now decreased by a little bit here. So because the component here has decreased, when you multiply it by B, the result of the vector product will be a smaller value compared to the A before this. Okay, if I go further down, okay, this is A sine 35 degree. If I go further down, now this is 25 degree, means that I'll be substituting in 25 degree here. So A sine 25 degree here will be equivalent to finding this component over here, A sine 25 degree. Again, we see that the component of A perpendicular to B has decreases as I decrease my angle. Because we are getting less and less perpendicularness, the component of A perpendicular to B is getting shorter and shorter. Therefore, the result of our vector product gets even smaller. Okay, I'm going to go fast. So this is 15 degree. And if you sub in 15 here, this is A sine 15 degree, even shorter because there's even less perpendicularness. So the component of A perpendicular to B gets even less, gets even smaller, thus the vector product gets even smaller. So this diagram here is trying to prove that the weaker the perpendicularness between A and B, the smaller the result of the vector product. Okay, the magnitude of the vector product. Okay, so I'm proving point number 2 here. Then lastly, let's go to point number 3. So point number 3 mentions about commutative rule. Okay, so if we talk about commutative rule, you might think that commutative rule, I'm reverting to the original stuff. Commutative rule is probably moving like this. That's what you might think should be. That's what you might think about commutative rule. If you think like that, then yeah, now it's resolving B to find a component perpendicular to A. So if we resolve B, then it will be something like this, drawing a line down here perpendicular to A. The component perpendicular to A will be opposite over here. Okay, opposite. So this will be B sine 45 degree. And if you're not sure how to get it, again, this is the 90 degree, this is the hypotenuse, this is the opposite, this is the adjacent. Now sine 45 means we're finding the opposite, and this will be B sine 45 degree. Okay, why do I say B sine 45 degree? It's perpendicular to A. Okay, if I shift it down here, then probably it's clearer. B sine 45 degree is the component of B that is perpendicular to A. So we can find the magnitude of B cross A by taking this B sine 45 degree multiplied by A. Okay, well, your maths, your secondary school maths might probably tell you very firmly that if I flip the position between A and B, I should get the same answer. And yes, indeed, if you take the magnitude of A here multiplied by B sine 45 degree that you get here, you get the same answer as taking A sine 45 degree multiplied by the magnitude of B. Same answer. But does that mean that it follows the commutative rule? No, because this is a vector product, and vector product, we don't just care about the magnitude. We have to care about the direction as well. So what I did just now by flipping the direction here, it's not commutative rule exactly. Commutative rule should be switching the order at the vector side, not this side. Okay, so if you're switching the vector here, switching the side, you can do your right hand rule again by trying to find if A cross B, what is the direction? If B cross A, what is the direction? Okay, you find that if it's B cross A, right? B cross A will be like this, then you find that it's pointing out the page. Whereas if it's A cross B, it will be like this. So it's pointing into the page. Do it yourself. The camera here might be distorting what you see. So do it yourself. Put your palm, flip your fingers, and then you'll find that A cross B is pointing into the page. B cross A is pointing out of the page. Therefore, you see that the direction is different. Therefore, it does not obey the commutative rule. Mistake, commutative rule, not law. Okay, so this is the third point being proof, and that's the 3 things that we learned being visualized on a diagram.